All right, so today we have our monthly roundup with our regular guest, Paco Nathan, founder of Derwin, and also now principal developer relations engineer at Sensing, where he works on graph AI and graph intelligence. So Paco, welcome back, and let's jump into our roundup, and I'll start.
Thank you, Ben.
All right, so traditionally, and I'll stick with it in this episode, I normally start with some update on large language models, and I'll do that slightly kind of indirectly. So by the time this airs, the folks at Anthropic have already released the 3.5 version of their Claude model. At least the first 3.5 version is called Sonnet. And it's, as we know, every new release, as Paco and I've hammered on this monthly episode, every new release is accompanied by some impressive stats against some benchmarks, against existing models, and so on, right? So, and that's the case here. So it's a good model, Claude 3.5 Sonnet. But what's more interesting to me, Paco, is this notion of artifacts. And unfortunately, the only way to really get a feel for it is to try it. So you would have to go to Claude.ai. It's not turned on automatically. You will have to go into your settings and opt into it. So what Artifacts does is it has a separate window for complex output. So for example, you might have a prompt where you ask Claude 3.5 Sonnet to write some code. So then it will write code, it will display it in a different window, in your browser side by side. And then now it becomes interactable. You can edit it, and you can continue to collaborate with Claude and work on it. But to me, what's interesting about it is, for all the discussion Paco and I have had on a regular basis on new models, this is an interesting development on the interface side. And I think that I'm looking forward to other communities, competitors of Anthropic, to also wow us with some new innovations on the interface side, because I think while the models continue to get better, to some extent, there's some kind of steady state nature in the models. They're getting better. That's great. But introduce some new ways for us to interact with these models and get us more kind of productive. So that's my update on models for this month.
Great. Well, I haven't used Claude. I haven't used this, so I'm really curious. As you're, say, generating some code, you can go in and make edits on the code. Will Claude then recognize what you've done and then work with it, like add to the changes that you've made?
Yeah. So it's still, large language model. So it's prompting. So you interact with Claude with prompting, but now you have a separate window where you can kind of work with Claude together side by side, like you would when you're working with someone, right? So you would, here's my code. Now I'm doing something. What do you think? That kind of thing, right? So it's an interesting kind of development in the co-pilot direction, right? So in the where you're because right now, if the traditional way is maybe you prompt in instructions, it produces code, and then it's kind of like a scrolling down interaction, right? So then you go, okay, so what about this?
Right.
And then it'll spit out new code. But now you have a separate code window, and then you're working side by side with this model, right? So.
And that makes a lot more sense too. I mean, it really is, in my opinion, a lot of what we call AI are actually design problems. We see this over and over. Like if you're doing, an investigation to try to catch bad guys using lots of data and machine learning, it's a design problem, really. So I'm curious, and also like building code with people. So I'm curious because the typical concept that people have of software engineering. You've got some code, you've got some sample data, you've got some unit tests, you got some kind of criteria, and there's a bit of a workflow that you go through, and any modifications on the code, you probably want to go put in some breakpoints and see what it's doing as you proceed to the test and get confirmation from the test. So I'm curious to see if, I guess by using the coding copilots, this kind of traditional workflow is still a viable thing, but it isn't necessarily baked into the chatbots, but this seems like a step toward that.
Yeah, I would say it's an interesting new step in how people interact with the models. It's not a full-blown IDE. Let's not oversell it. It's basically just a more efficient way so that you can kind of do this iterative feedback. Here's some instructions. Here's the response. I give it feedback, and but you're not scrolling
Yeah.
down constantly and having it to
Right. Yeah.
repeat, because right now what you would do in a normal kind of interface, LLM interface, is here's the code, and then you'd go, well, this line that you have in there about this doesn't seem to be quite right. Can you redo it? And then it'll redo the whole thing.
Right. Yeah. I mean, this has been one of the telltale signs of the tech majors is that all the UI has had this like infinite scrolling. So whether you're on LinkedIn or, Twitter X or Facebook or Pinterest or any of these, it's like they're driving you toward infinite scrolling, just keep scrolling down. And it did seem like the chatbots were also following that mode, but I mean, real life is not infinite scrolling. So, okay, great development.
But it's just interesting to me that ChatGPT released November 2022, and we haven't really had much innovation on interface and UX, right? So looking forward to more innovation. And I don't know if listeners are familiar with the work of Brett Victor, and maybe we'll have developments along those lines even, right? So, all right, Paco, on to you.
Excellent. Okay, great. Well, I wanted to highlight there were a couple of articles that came across on Gradient Flow about challenges of generative AI and exploring this in some different ways. And I wanted to highlight that there were a few other reports along these lines. I guess I would characterize it as, you were saying balancing innovation and risk, but really on both sides, can we have some structure to that? I mean, what can we have a taxonomy to describe the risks so that we're comparing apples to apples when we make a risk assessment? And similarly on the innovation side, like where are the real opportunities right now? So I wanted to point out these two. You had challenges of generative AI and then generative AI navigating the challenges of enterprise adoption. And one is talking more about risk, and the other is probably looking a bit more on the innovation side. The first one referenced there was a new paper out of the German Federal Office of Information Security, Tobias Alt and others, generative AI models, and it is basically building up like a reference taxonomy of where they see risks and what they're measuring. And then similarly, Google recently published just a couple weeks ago, Generative AI Misuse, a taxonomy of tactics and insights from real world data. And so I thought it was interesting to look at these two together along with the articles that you had. Um, they're really kind of struggling with describing the same beast. I liked what Google did because they went through, hundreds of media reports and tried to summarize it into more of a framework that people can use. And they try to report like, what are the top three areas of where they see real trouble. Um, Also, some of the illustrations we don't have it here in the podcast, but if you look at the Google one, they have a nice Sankey diagram that shows what are the techniques versus how are they being used for some sort of exploit, and a fair amount of quantitative analysis of that. So I guess what I'm trying to surface here is there's some more conceptual tools to try to understand risks and opportunities, and so that people aren't just using large words like trust, which may or may not have a real tangible definition. But instead, here now, we're actually drilling down and we're saying, hey, look, we see people doing impersonation by using audio or video, and here's the percentage of time. We see people doing appropriated likeness in images, targeted personalization, etc. I'm glad to see that there is more of a breakdown of the risks and more of a refinement of our language about it, because I think for a long time we've talked about trust and safety at very, very high level, and everybody shakes their head and says, yeah, great, we have to have trust and safety, but what does that really mean? And so now we can start to talk about, well, where are the risks within the life cycle of working with an LLM? Like, where are risks being introduced at every different phase? And how can we audit for this? Plan for mitigating it, but then also go back in and have some kind of common rubrics for scoring or assessing, which is something that, in the security space, you always need that kind of common rubric to get people to collaborate. So generative AI, there's upside and downside. We're trying to wrangle with really describing both of them better.
All right. So just a quick comment, and then I'll go into my next thing. So on the gradient flow article, so one of them, as Paco mentioned, is based on a paper from a German agency, but basically it's a taxonomy of risks for generative AI applications. So what particularly caught my eye is kind of the top level description of how they do it, right? So there's risks that emanate from proper use of LLM. So in other words, even if you do everything right and you use this thing as intended, things can still go wrong. And then there's risks from misuse. So you literally use the LLMs to do nefarious things like misinformation or social engineering. And then there's risks of attacks from LLMs. So I think the reason I kind of put it together as a short post was that I thought that it was worth highlighting this risk of proper use. So in other words, sometimes I think people think that the risks only come from attacks or misuse, but really, literally, even if you use it properly, there's still limitations, right? So I think people are familiar with things like hallucination and things like that, but you can also imagine the LLM if you, with good intention, use it to generate code, but the code has some kind of security problems, right? So your intentions were good, but it produced some problems. And then the other post was about essentially why your generative AI projects are failing. And I think that part of my motivation there is we're midway through the year. And while Paco and I tend to be on the cheerleader side of generative AI, I decided this is a good time to take all of some recent surveys and look through not the positives, but what they highlight as challenges. So that's what I did there. Was I looked through, I think, 8 surveys, and then including some of ours here at Gradient Flow, and then I created kind of a short slide presentation, which I turned into a post that highlighted some of those challenges. So again, mostly to get people to think about the fact that if they are struggling with generative AI, don't worry, you're not alone. Basically, that was my goal there. All right, so now jumping into what Paco just said, my friends at Luminous.law and Luminous.ai and I have recently written a post. It's actually not out yet, Paco, but it will be out by the time this podcast airs, called "What is an AI Alignment Platform?" And the motivation there is, as Paco mentioned, right? So there's risk from using generative AI and AI in general. And as Paco pointed out, there's a lot of good work around formalizing and systematically classifying those risks. But, at a very high level, let me just paint broad strokes, right? So there's risks around security, privacy, bias and fairness, and then also copyright, right? So when it comes to generative AI. So then the challenge for teams is that think of just these four buckets, right? So security, privacy, bias, and copyright. In a typical company, each of those risks tends to be addressed using different tools, different teams, and different experts, right? So you can imagine as a organization trying to scale your generative AI practice, and now you are kind of faced with this multitude of risks, and each one of which you will need some expertise to tackle. And so that's kind of the motivation for, and now I'm going to share my screen quickly here for us kind of thinking through, right? So you have these fragmented AI alignment solutions around security, privacy, bias, copyright, and maybe you can throw in transparency and disinformation. Each one of them, you use different tools and different teams are responsible for them. So our vision at Luminos is to create an alignment platform where you can kind of have different teams collaborate and manage these risks in a centralized and formal manner. And this platform then will have, we'll use open file formats, open APIs, and things like that, so that people can even plug in their own, bias models, what have you, right? So, but I think as people scale their generative AI practice, they will find more and more need for something like this, because it's untenable to continue to use multiple tools and rely on multiple teams if you want to move fast. And so that's it.
Well, interesting. I'm curious about what you foresee as far as implementation. This brings up a lot of dialogue that was going on about 5 years ago in terms of ML ops, because the thinking was at the time that people were deploying, I don't know, CNNs or whatever, some sort of machine learning enabled products. And typically the operations people were on the hook. So if there were customer problems being reported, something was failing, there had been model drift, some sort of regulatory problem, the operations people were the ones who were on the hook, even though they hadn't developed the model. And you ended up with this kind of triangle between, say, operations and where did the models come from, maybe a data science team, and then typically what would evolve would be like a GRC, like a governance, regulatory, and compliance committee made up of other stakeholders outside in the company. And between the three, they had to have a lot of dialogue and figure out what really is the problem, what should we do for any issue that would come up. Do you foresee that there's, for deploying this kind of framework, is there guidance or advice about how to build out that GRC component now that we have a lot more concerns, or rather the concerns have evolved?
No, in some ways, I think this vision for a alignment platform makes all of that much more seamless and built-in, native in some ways.
Okay.
So the idea here is that I think, to your point, Paco, a few years ago, right? So we were obsessing about ML ops, but to a large extent, that obsession was around technical performance and DevOps and more on the technology side, right? So what we're saying here is that an AI alignment platform is something that will manage all risks that cut across performance, operations, legal, is an important thing,
Mm.
right? So compliance and reputational, right? So the legal piece is important because most technical teams, frankly, and they shouldn't be
Sure.
aware of
Shouldn't
all
be.
the legal minutia that they have to comply with. And so the idea here is that now you have a place where legal and technical can collaborate, right? So, and the grand vision here is that you move towards a notion of the best model being the most helpful, but the while simultaneously being the least harmful, right? So high helpfulness, low harmfulness. Um, I think before we were too focused on high helpfulness, right? So accuracy
Yeah, yeah.
and all of that. But now we have multiple stakeholders and multiple risks. And with that, on to you, Paco.
Great. Let's see, I can probably share my screen real brief just to set this up. There we go. Okay, RAG deconstructed. So there's a few articles, there we go. A few articles showing really what are the components that are being used inside RAG, and now there's a lot more discussion about using graphs with RAG. I think a lot of the emphasis I'm seeing currently in terms of how do we provide less hallucination, faster updates, more reliable results coming out of LLMs. We want to be using RAG, and we're seeing increasingly that there is proven lift by using graphs along with RAG. Although I think, having been working with the libraries and working with examples and trying to build some of this out, I mean, one of my frustrations in this area has been number one is, as you pointed out in an article last month, the term graph rag means several different things, and so I was glad to see this paper coming out of Automatic and AI Alliance, where on the one hand they really pull it apart and they provide some conceptual framework for what needs to happen in RAG. And they applied a OODA loop to describe some of this, which I thought was interesting. That'll resonate with a lot of the business crowd. But also, quantitatively, they were showing getting lift by working on the embedding models. I thought that was interesting because I hadn't seen a lot of other people working toward that line. And it was something that struck me as like, huh, I wonder if that's been overlooked. So,
Yeah,
yeah.
that's a bit surprising because most people will tell you that actually chunking is more meaningful. So the embedding models
Well,
obviously help, but if you had a gun to your head and you only had to choose one thing, chunking would be the way to.
True, yeah. Chunking, understanding the level of chunking and understanding how much overlap. I mean, yeah, there's obviously a lot more
Yeah. So all
sensitivity
all
a
all
result.
all are helpful, but I think most of the people I talk to, and at least also from my personal experience, gun to your head, only try one thing. I think chunking. You can
Although
only have time to try one thing. Yeah.
And that leads into I definitely have really enjoyed so Tomasz Botanek and Oscar Hane had a new book that's out in early release called Knowledge Graph Enhanced RAG, and they also break this down. It's like, hey, there's really four components, and they illustrate pretty well as far as like, here's a fragment of code to do chunking. You can see the different parts, how to parameterize it. What is the pros and cons of different strategies for chunking, and how does this spill over into leveraging a graph? And a lot of the bottom line there is that, well, we say the word graph, we really mean a few different things. It could be a graph of the embeddings, how they're linked together through similarity measures. It could be a graph of a parse of what's gone into the chunking. It could be a graph of the prompt being decomposed. Um, so I think that this here has a pretty nice framework, at least to understand it, and a breakdown. And I think that this new book by Botanic and Honey, they're breaking it down. They're showing a lot of code fragments. Um, Along with that, What's definitely emerging is a lot of names in this space. There's GraphRag, GRag, KGRag, Graph Enhanced Rag. I'm kind of leaning more toward Graph Enhanced Rag as probably being more of the point. When you look into the code that Microsoft released, they're using NetworkX, they're using an in-memory graph. And I think
Paco, for as wearing my marketing hat, Graph Enhanced Rag and Graph Rag are almost the same term, but Graph
yeah,
Rag is shorter and it's already out.
GraphRag is shorter. I mean, Microsoft marketing is going to own that one now. Um, I think that out of all this, though, the
Well,
one
only
caveat I
only
would,
from a perspective of we were the first, right? So just like at Databricks, we were the first to do Lakehouse, but now Lakehouse is a term. And RAG itself is a term that Meta people introduced, right? So, but Meta
right, right,
obviously Meta is not marketing RAG, so most people don't realize that the term RAG was first introduced by Meta. But Graph RAG being introduced by Microsoft and marketed by Microsoft, fine. We'll surf behind you. I don't mind.
I did like there have been increasingly more articles illustrating where the pain points are in this. I picked out one, Jeremy Ravenel. Especially concerned with what we're seeing
I
in
wrote something
GraphRag.
like this a while back, actually. The
Oh, yeah.
Yeah. That's I think yeah, that's good. It's good that people are going back. But what's your sense in terms of um, the graph rag term? I think most people are still, frankly, like as you noted in your first item, people are still kind of working through the mechanics of how to do rag well, and graph rag is an additional level of sophistication. But I think that people are intrigued enough that they've at least heard of the term, right?
Yeah, I definitely there's a lot of interest, and a lot of interest for people gaining hands-on. You see this in the conferences now, any kind of hands-on. The point about it though is I think that LangChain and LumIndex and Haystack and all they've put together libraries that kind of wrap it and automate parts of it.
Ooh,
Maybe encapsulating it in ways that aren't quite as transparent. I like what's going on here because now people are starting to pull it apart and say, well, these are the
yeah.
components that you manipulate. I also think that there's way too much emphasis on automated graph construction, and there's a danger in that. You can see this when you're doing, for instance, work in fraud. The automatically constructed graphs might actually accentuate the fraud as opposed to revealing it, because they don't understand the domain, they don't understand the mechanisms that criminals are using, and so they make naive assumptions about how to put a graph together, and actually, they complicate the problem. I think that it's great to be able to take some raw data and build a graph and say, hey, look at the results. But unless you have some real means of evaluating your use case, those are just results. They're just pretty pictures. And too much of what's going on in the automated graph construction, I think, is sweeping the dirt under the rug and creating a lot of potential liabilities out in usage.
I think it's a good starting point for people who are not uh, familiar with how to create knowledge graphs, but only in the sense of low stakes settings, right? So where you're just kind of trying to figure out what's in my PDF. So maybe I'll throw in a little graph, knowledge graph to enhance my RAG. Low stakes, where if you make a mistake, sure, it's fine. Um, but I think that a couple of things. One, what you said, where people are kind of obfuscating, and instead of, like you said, the nice thing about pulling things apart is you know exactly how your system is behaving, and if things go wrong, you can diagnose. So I'm not a fan of kind of here's a massive framework where I don't know what's going on, but
Right,
there's graph
right.
rag involved. Yeah, I don't like that. And secondly, the second point you made about automatic graph construction, I think ties nicely into my first item around artifacts and interface, because maybe
Yeah.
perhaps the direction we should be in is there's some sort of automatic knowledge graph construction, which then a domain expert can go in and inspect and kind of make sure it's okay. You know, up to a point, obviously graphs get big and it becomes impossible, but you know, how do we build tools where domain experts who know the data well can participate? Obviously, in the past, people will have teams building ontologies, but now,
Well, let
now,
me
now
stop you
that,
there.
but now that we have better tools, perhaps there's ways to innovate on the interface side to help people,
Well,
right?
let's bring this back. I mean, one of the concerns you brought up is like, well, these graph techniques are interesting and helpful, but not a lot of people have hands-on. They don't really understand graph. Let me take a little counterpoint there. In security, there are tools where people are going and doing cybersecurity investigations and trying to figure out who are the actors, what are the methods, what's being attacked, and the typical cybersecurity investigations, they are in fact building graphs. They're building rather interesting
Yeah,
and large
our
graphs and
friend, our
layering on
friend
more data.
Leo. Yeah, our friend Leo.
Uh,
That's his domain, right? So
well, security workbench notebook. What is it? Security analyzer notebook. I mean, there are things that are very
yeah.
predominant in industry. And the professionals who do the investigations, they work the graphs all day, every day. I think that it's not as highly recognizable because a lot of these kind of people don't really talk about what they're doing. Police
No, I mean,
departments don't
I go to
show.
RSA every year, so this is something that
Yeah,
I know
definitely.
exists in that domain, but that's a one domain.
Well, okay, but I mean, whether you're talking about banks doing anti-money laundering or KYC, or you're talking about, police department doing some sort of investigation for racketeering, um, these are practices that are out there. And I guess what I'm saying is these people understand the graphs that they build, and they build very sophisticated, they do work. The AI tooling that we see says, oh, let's just throw all that away. We'll build the graph for you. There's not a lot of support yet for
No,
acknowledging that actually,
I'm not proposing
yeah,
that though. I'm
yeah,
proposing use the AI tools to get a starter graph and then innovate on the interface side and maybe bring in some of this knowledge from these other domains that have deep experience building graphs well. So in other words, use everything in your toolbox to broaden the pie beyond the useful domains of security, money laundering, fraud to other people who are not graph sophisticates.
yeah. It's I
Now,
mean,
I guess that's what you're trying to do in your work
well,
at sensing, right? So it's to broaden make it easy so that people who are not graph sophisticates can participate, right? So
I mean, we keep a very narrow focus, so no, we do try to work with people on that, but there are other people who are doing that. I'm looking more at like the libraries that are coming out for GraphRag.
yeah.
And the thing is, they make a lot of strong assumptions about where the graph is going to come from, and frankly, it's going to come from what they've done.
Yeah.
And what I'm saying is, you have to acknowledge, no, there's already a lot of existing graphs, whether we're talking about supply network analysis, or we're talking about value chain in
But
finance, or
that's
we're
not
talking about,
I would suspect that's not their audience. Their audience are the people who don't have graphs, who want to bring in
uh,
graphs. The people who have graphs will probably
yeah.
figure out other ways besides using their framework that automatically builds a graph. So in other words, so there's the population of people who don't have graphs but have heard of GraphRag. That might be their audience, as opposed to the people who already have graphs and just need to add their graph into the graph rag. I think I don't think those guys should be using these frameworks, frankly. You know?
Well, I mean, you can build your own. You don't have to use some library for RAG. It's a little painful, and I think the lesson learned is these kind of applications are really expensive and time consuming. They take a long time. It would be nice to have some libraries to work with. The libraries that are available are really not flexible enough to use with an existing practice. And that's a big disconnect. I am hearing across the industry, not just talking about like where we look at it work, but across the industry, a lot of people are interested in leveraging GraphRag. The tooling doesn't really account for the fact that there may be an existing practice. So
Yeah,
I'm
no, I mean,
hopeful that some of the developers pick up on this
Like I
It's
said,
definitely an opportunity if anybody's listening.
like we said earlier, I mean, even RAG people are still struggling with, building it in a principled way where they can figure out if they've turned all the knobs optimally. And
Yeah,
basic
yeah,
RAG, forget graphs, right? So, I mean, because
yeah. Some are
even
better than others, definitely.
even basic RAG requires that you are able to conduct experiments at scale, right? So this is what the Anyscale
Yeah,
people have been kind of talking about, right? So yeah, you want to go through different embedding models and different chunking strategies. Well, guess what? That's computationally expensive to try different permutations, right? So a lot of people, I think, need to work through that, and then maybe once they get a little more savvy there, let's bring in a graph, right? So just basic RAG, and then bring in a graph. All right. So then my next topic, unfortunately, goes down the same road of being a bit of a downer, um, in the following sense, right? So again, my philosophy here is we're halfway through the year, um, and let's carefully look at the generative AI landscape and kind of assess where we're at, right? So, and so what I did here is I kind of, so this is I'm sharing my screen for people who want to use the video version of this podcast. But basically, the idea here is that I put together kind of by reading a bunch of analyst reports, talking to people, and thinking some of these issues through. So midway through 2024, what are some positives? What are some negatives? What's up in the air, right? So a lot of this, I think Paco and I have already covered here, right? So
Hmm.
obviously on the negative side of generative AI, I think we don't talk about it enough is power consumption, right? So uh,
Yeah. No, I know.
I think sometimes I think we focus on power consumption from the perspective of people building the models, but there's also power consumption once we use the models, right? Um, and then I think there's a bit of a uh, not as much talk about revenue gap, right? So I mean, I think that people are investing in these technologies, but what's the ROI? I think people are, if you look at even the suppliers of the technologies themselves, I don't. I think Microsoft might have the most revenue, but even that is not, you know, a fraction of their
Those are
revenue. So this is we're
yeah,
more kind of hopeful at this point than actual revenue, right? And then there's
yeah.
also for the builders, there is a concentration of revenue on the top, right? So OpenAI is getting a lot of revenue, but what about other startups in this space? I think there's a lot of uh, everyone talks about a bubble in AI startups, and I think we can agree that that's probably the case, right? So a lot of startups building tools, but very little revenue to show for. On the neutral side, so you can say the technology is still evolving. We're still kind of uncertain about how this will translate to revenue, so let's not panic. So this is much more of the neutral kind of perspective, right? So and then to some extent maybe the GPU supply is uh, easing a little bit. Um, and on the positive side, I mean, you can see the people who have deployed generative AI. And Paco, from what you remember, from what you may remember, last year, Eric Brynjolfsson at the AI conference gave
Yeah,
a talk
it's a
on
good
that
talk.
first academic study on RAG and
Yeah.
fine-tuning models, right? So massive efficiency. I think double-digit gains in productivity for technical support workers, right? So for an enterprise software company, real data, not a bunch of grad students testing it among themselves,
Right,
right?
right.
And then on the bubble side, you can say, well, a lot of the investment and R&D is being done by incumbents with deep pockets, right? So Amazon, Meta, Microsoft, Google. So they can ride out kind of any kind of slowdown. To me, on the positive side, one of the more hopeful things is AI might help us in actual science, right? So we're talking AlphaFold, right? So I
Yeah.
recently wrote a piece, and I might revisit it briefly here in this episode about uh, machine-assisted proofs in math, right? So there are some hopeful things there, especially on the scientific front, especially if you're thinking more on the co-pilot side. I think people are getting carried away with agents and complete autonomous systems. I mean, just this week, I've talked to some people who think that, AI can write all sorts of really sophisticated code without human supervision in the short term. I just don't know if that's going to be the case because, if things will go wrong. So how do you know how you still need some human oversight there, right? So anyway, so this is just something that by the time this episode airs, will have been in one of my newsletters and on the gradientflow.com site. This taxonomy of the highs, I call it the highs and lows of generative AI. So.
I'm curious on the power side, are you also talking about like, for instance, not only is there a lot of energy consumption, it's also a lot of heat generation and a lot of fresh water
Yeah.
consumption that's being used to address the heat generation.
Yeah, I think that all of that, I think maybe I just kind of swept into this bucket, but all of that are valid points, right? So that
Yeah.
there's these environmental ramifications, right? So, and I
Well,
think this is why I think, you know, set aside the training of the models, but the deployment and inference, the fact that people are working hard to make that cheaper and cheaper and run faster on less sophisticated hardware, those are all good signs. But
yeah.
much more has to be done because as Paco and I have alluded to in this podcast, right? So things like GraphRag, those are still in very nascent stages, but you can imagine if people start going nuts and doing GraphRag right and left, that's gonna be the inference on that stuff is gonna be high as well, right? So
Yeah, it does beg the question of like, if we're not seeing the ROI just yet, why are we blowing up all the carbon in the atmosphere for it? I mean,
so one of my explanations there in my post is as no surprise, Paco, FOMO, right? So fear of missing out.
Sure,
So
yeah.
yeah.
Well, I mean, part of the concern though is this is coming on the heels of like we had so much hysteria about crypto and Web3 and Bitcoin, et cetera, and all the mining, and you see these egregious cases of like power consumption and what's happening in communities where someone can get cheap compute. And in the case of the crypto miners, one server could be taking the entire power requirements of three-bedroom home. And so you're really offsetting the power availability and the fresh water availability in a lot of communities, doing some damage. And now we're seeing a lot of FOMO rush toward these huge AI consumption of resources. Similarly, on top of the existing crypto, it's really stressing in certain areas. European Union has now made it has made regulatory compliance such that the tech firms are having to disclose their power and water consumption and also disclose what measures they're taking to try to mitigate the needs for this. I think there was a PBS segment recently that had Reid Hoffman very optimistic about AI, how AI was going to solve these problems, which I found curious because we haven't quite seen the level of solutions being commensurate with the level of resources yet, but hopefully.
Nuclear fusion, Paco, nuclear fusion. But
Cold fusion.
I think that the defense of AI and generative AI, at least we have use cases, right? So
Yeah.
crypto, great store of value. That's the use case, right? So anyway, on to you, Paco.
Well, okay, so one that I find very hopeful and very encouraging. This is the news that came out of a company called Evolutionary Scale, and there's the ESM3 model. Uh, I mean, it's fairly large, a 98 billion parameter model. And I'll quote from it. Its training task of predicting the next mass token. Model must learn how evolution moves through space of potential proteins. So if you think about how is it that maybe proteins could connect, the proteins themselves in evolutionary process probably don't know about any sort of end goal. They're just kind of connecting and seeing what sticks, what evolves over time. But time is the question there. How many millions of years does it take for certain proteins to come together to produce particular features, so to speak? In this case with ESM3, they were trying to evolve toward fluorescent proteins, kind of like you see with deep sea creatures, where you can get this like light generation coming off of biological processes. And what they were able to do, though, was to leverage large models to speed up what would be happening in a kind of evolutionary process. So they were able to find a new protein. It was only 58% similar to the closest known fluorescent proteins. So it was something novel. Um, but they were able to, by estimates, if this had been going on out in biology, it would have taken approximately 500 million years to reach this stage of evolution, and they were able to cut that down into very short time using large models. So the tagline there is essentially an evolutionary simulator for areas of biology if there's something you're trying to drive toward. And to me, it really recalls a lot of the discussion that was around genetic algorithms and genetic programming, especially John Koza, but like late 1980s, 1990s, we were saying one of the benefits of using this kind of machine learning technology is that we can approximate what's going on in evolution, but we could speed it up if we had the compute power. Back in the 90s, we didn't, but now we do. And this is actually a proof point for more of the positive case you were talking about. This is where we can actually demonstrate some of the upside of why these technologies can take a very hard problem and speed it up.
Yeah. So this is kind of one of the items I have in my graphic, which is AI's role in scientific discovery, right? So
Yeah,
yeah.
very big.
All right.
Well, I just add, I mean, also the weather models, the climate models, the immense speed up on those for like predicting what's going to be happening with a hurricane as it's approaching landfall. There's so
Or
many benefits for them.
AlphaFold, right? So all right.
Yes.
So very quick rapid fire topics and then close with recommendations. So two rapid fire topics in my and one is LLM routers. I published a post. So if you were to ask me about a year ago, early 2023, so routers basically allow you to kind of pick the right LLM for the right task and right requirement, right? So whatever you have, latency, cost, and things like this. So LLM routers, maybe early February, early 2023 was being discussed. I would say it was a bit of a thing that mainly more advanced teams were talking about. Now I think it's clear to most people that one model is not enough. You have to use the right model for the right task for the right price. And so I wrote a post, LLM routers unpacked, which you can look through the kind of the state of LLM routers, and I also make some predictions about how that will evolve. And then my other rapid fire topic is lessons from AI's role in math. So where I talk about machine-assisted proofs, mainly because I came across a talk by Terence Tao and some articles about Terence Tao's work on this area. So Terence Tao, for people who don't know, is Matt Big Brain, a Fields medalist based in UCLA. So anyway, so the point of the article is there might be lessons there because basically for them, AI is a co-pilot and an assistant that allows them to really do things that maybe they won't be able to do. But obviously, they're still very much involved. And not only are they involved, they can now also involve many of their friends to tackle even bigger problems in math. So again, so think of AI in math as a potential role model for how we might use AI elsewhere. So those are my two rapid fire topics: LLM routers and lessons from AI's role in mathematics.
Really interesting. My rapid fire topic, we'll link it here, but the FTC put out a brief article, a one pager really. But the title is great. It's called Sucker Born Every Minute, SUCCOR, and born is BORNE. And it's basically their caveat is like, hey, we're seeing a lot going on in terms of quote AI unquote services, which has come to our attention as far as Federal Trade Commission. Some of these practices are getting a little shady. So, this is an advisory. I think it's a very humorously written article, but also very salient. So I will definitely point to it. But they are watching, and I think it shows some very keen insight on the part of the FTC.
All right, so close with recommendations for me, it will be summer books since we're in that time of the year and they have nothing to do with AI. So the first two are kind of take you to other countries. The first one, and they're written by two of my favorite writers. So the first one is Impossible City, Paris in the 21st Century by Simon Cooper, who is normally writes for the Financial Times. And then the other one is Other Rivers, A Chinese Education by Peter Hessler, who normally writes for The New Yorker. Both excellent, excellent books that are super well written page turners. And then the last book is Private Equity by Carrie Sun, where she talks about her experience as an executive assistant to one of the largest, I would say, hedge fund slash tech VC firms. That she doesn't name, that I think people assume is a fund they know about. But basically, what's interesting about this is she actually has a double major in math and finance at MIT and worked as a quant in the industry for a little while, but decided she wasn't interested in that. She wanted to be a writer, and so she found a job that she thought she could do while pursuing her career as her passion as writing in weekends and in evenings. But it turns out being an executive assistant to one of the billionaire hedge fund managers is basically a 24/7 commitment. So anyway, all three books are worth picking up, and I will link to all of them in the episode notes. Paco.
Great. Well, I had a link. It's something I thought was a good discussion. It's called Seven Themes for Effective Human AI Teams. And this gets back to some of the discussion we had about the importance of design and different modalities and just, where does UX play? I liked it because it was the idea of having norms for human AI interactions. That was point 5 out of the 7. Something to think about. We've definitely got a lot of AI augmentation showing up in business in different places. How do we socialize that is kind of the bottom line. And so how do we incorporate that in a way that is fluid, that is helpful, that tries to make the best of both sides. And developing these norms is, again, it's a little bit more intricate, happens over time. It's it's more work than just saying I'm going to go to ChatGPT and get my answer from a chatbot. But it is much more natural in the workplace of how people collaborate, and it speaks to more of the kind of working definition for AI that I've subscribed to for a long time, which is teams of people and machines collaborating together.
Excellent. And actually, this ties to that post that I alluded to earlier about why your generative AI project is failing. One of the things that I noted there from multiple surveys is the teams that seem to succeed are the teams that listen to users and their employees. So in other words, you can't just shove these tools down people's throats. You have to actually pay attention to how they're using them and get feedback and continue to improve that human AI interaction, which is how we started this episode. And with that, thank you, Paco.
Thank you, Ben.